Hello everyone, it's me again. We're going to go through a quick primer on affinity chromatography. So, affinity chromatography is a very specific form of chromatography as far as the binding goes. It separates a molecule from a mixture based on binding to a ligand. So, you have a binding relationship between a specific ligand and your analyte. Usually, the beads that we use in this are either agarose or polyacrylamide. They've been chemically modified to introduce reactive groups, and that's how the ligand is put on the resin. So the basics of affinity chromatography are that it tends to have less steps than other forms due to the specificity. The specificity of binding allows for very stringent washing and purification with very minimal steps compared to ion exchange, size exclusion, hydrophobicity, and other types of chromatography. The main advantage of affinity chromatography is that it does not require molecular weight, charge, hydrophobicity, or other physical properties of the analyte of interest to be known. The only thing that you need to know is the binding properties of the analyte to the ligand. Just a note about ligands. Chromatography ligands, affinity chromatography ligands, bind to specific targets with high affinity. They are used in affinity chromatography, which exploits specific interactions between the two molecules. The affinity chromatography ligands are obtained from organic and inorganic sources depending on the binding properties that we're looking for. So several of the types of affinity ligands are serum proteins like protein A, lectins, and antibodies. Inorganic sources are moronic acid, metal chelates, and triazine dyes. And we're not going to go into what they're used for in this lecture because we're mainly focusing on protein purification here. By this point, everybody should be reasonably familiar with isocratic versus gradient elution. Typically in an affinity chromatography purification scheme, you're going to default to an isocratic elution because you will be able to very stringently wash the column, get everything that is not your protein or analyte of interest off the column, and then switch to an isocratic elution to get a nice tight and tall peak off of the column. It's we've used it in class with our pH change, and everybody now by this time has seen how the peaks come off from protein A antibody elution. Okay, so elution techniques continued here. So there are really two types of elutions that are used on affinity chromatography processes. One type of elution is a specific elution, which uses a competitive ligand. A good example of this is his-tag proteins on nickel columns are eluted by adding imidazole. And once you bump the protein off the his-tag nickel relationship, the binding with imidazole goes in, it binds tighter to the nickel and bumps the protein off. there will be an excess of imidazole, so in a scheme like that, you often have to do uh, um, a cleanup later. So that would be either size exclusion or dialysis in some cases. Non-specific elution is what we perform with our protein A uh, antibody purification. We used pH. Typically, that's what you're going to see in the majority of protein purifications is a pH change. You can use salt in some cases. Polarity or other conditions can be used, but they are more rare, and polarity is going to be reserved for things like hydrophobic interaction, which we will get to in another lecture. Now, we've already talked about this, and one of the prime strengths of affinity chromatography is it can be used in a batch method. So you can actually take the resin that you have conditioned in your binding buffer, mix it in a centrifuge tube or a centrifuge bottle, um, and batch bind and do your primary washes of your lysates, let's say, in a batch method using centrifugation, which is a very fast method, especially for large purifications. Then if you choose to do so, you can load that directly onto a column with the analyte bound to the ligand and do a final wash on the column and an elution. It's an industrial technique that's used quite often for purification of very large amounts of protein. Okay, that about does it for affinity chromatography. There will be some links to videos on the YouTube channel. I will be posting the YouTube channel later today.